Hi, welcome back. I've been sort of busy at lots of different bits over the past few weeks. So I haven't really got anything complete to show you, but I've been working on quite a few things. So let's dive in. A friend of mine has got a Boxford CNC machine, and the motor on it kept blowing a fuse. So I said I'd have a look at it. This was the speed controller that was with it, and had a brief sort of visual inspection. Nothing looked bad on there, but just to rule that out, I used the original DC motor drive out of, it was either my mill or my lathe, can't remember which, and spun the motor up. Motor works fine until it gets to a sort of quite high speed, and then you can just hear arcing shortly before the trip goes. So I think the motor has had it. I've had it apart. I've given it a good clean off, trying to get all the carbon off. I gave the commutator a skim and a clean up, deburr and everything, just to see if that would improve anything, but it's still doing it. So I think there's insulation breakdown in the windings. It must have overheated at some point. It does look a little bit brown. Unfortunately, that's a duffer, but I do still have the old 1 kilowatt DC motor off my lathe, which can be driven by this. So I'm going to offer him either this or this. I think it's a 400 watt brushless DC motor that I don't currently have a use for. Obviously, if he can get his CNC working, I may have some work for him. We'll see how that turns out. Moving on. I've done my first PLA burnout with the kiln and poured it. This is not the exact model, but I basically printed out one of these and with sprues and feeders and breathers and all sorts, encased it in special casting plaster, burnt it out, and then poured some aluminium in, and this was the result. Now, it isn't perfect. We've got quite a lot of porosity. We've got a few bits where it looks like there's bits of plaster have fallen down into the mould. There's sort of slightly missing bits, and we've got some big holes here. Now, I think most of this, well, there's two reasons for this. So it was a great big block of plaster, and I think it probably needed a lot longer to dry out, because I think there was still steam coming out of it. I followed the standard burnout time of the data sheet just because I never done it before, so I don't really know. But having done it, I've learnt a fair bit, and yeah. So there was, I think there was still steam in there, and also the burnout temperature for the PLA, I don't think it was hot enough. It was 230 degrees, and I mean I run the 3D printer at 215, so it's probably not hot enough. So I think that should have been hotter, and I think these voids and lumps and missing bits are because there was probably still lumps of plastic in the mould. The bottom is probably better than the top here, because this would have had a very thick bit of plaster around it, like sort of like that, whereas that I don't think was terribly thick at the bottom, so the heat probably got to the bottom better. And I'm very surprised this came out, because the breather that was coming off this, no aluminium came up that at all, so I think that was plugged with molten plastic still. It had burnt out by the time I came to break this out of the mould, but shortly after I poured it, I poked the hole that should have had aluminium coming out of it here with a welding rod, and I could just feel gooey plastic at the bottom. So I'm fairly pleased with that. It's come out fairly well. I've got obviously some work to do to make it better quality, but I think that's all doable. It's just getting the parameters of the process right. Now, so another thing, in order to machine this is for a V8 engine, so it's a 45 degree V, which means that this is the head side, so this will be at 45 degrees. This is going up to a plenum, which is sort of horizontal. So I'm going to need to mount this 45 degrees to skim each face, and then mount that one and skim that face. So with that in mind, I've been shopping at Art Eurotrade again, so there's nothing in the box anymore. I've already unboxed it, and here's the box that was in the box, and that's empty as well because I've already been playing with it. Got myself one of these tilty angle tables, so currently got it set at 45 degrees there, and took a little bit of checking the different sizes of these things to determine which one was optimal for this machine. And this is the 5x7 inch model, and the bolt downs fit my T-slots. So this one I haven't done up yet, but it will do. It fits my T-slots perfectly. So that is the head at maximum height, and you can see I've got a good bit of height, so I'm going to have to skim these. So I'll probably use a fly cutter or something to do that, and then I'll need the boring head to come down inside these bores just to clean those up, because they've got to have induction trumpets pushed into those. Then we will need to flip this over, and that will require a skim. So I'm really pleased with this. It's really rock solid and steady once it's all bolted up. It feels kind of good. So I can use my digital angle gauge to set the angle on there. So I've also bought this. Now this is an integral shank Morse 3 M12 drawbar for the mill drill chuck. The reason why I wanted to go for this was that the non-integral shank ones are significantly longer. So the body of this one is that long. This is my Morse 2 one off the lathe, and you can see that it's 10 millimeters shorter, which doesn't sound like a lot, but when you're fighting for every millimeter with a small mill such as this one, looks big from down here. You know, I thought it would be advantageous just to have that bit of extra room, although it was a bit of a challenge to find this exact combination. There's plenty out there with tangs on from all sorts of places, but nobody seems to want to sell me one of these apart from Amazon. Got it off Amazon, 50 quid, delivered. First time I bought it, it didn't turn up, but there was no problem getting a refund for that. It had clearly disappeared in the postal system somewhere, and yeah, there was a no quibble refund, which was absolutely fine. And then ordered it again. It arrived in about a week and a half. So all sounds quite good so far. The downside is that the accuracy of this chuck is 80 microns. That's the run out, which seems like a lot, and I've measured it, and it's somewhere between 80 and 100, so it's like 0.1 of a millimeter run out. So the other thing I've got is this bottle of Mirror Cut cutting oil. I have no idea how good it is. I haven't tried it yet. I wasn't recommended it. I just spotted it on eBay and thought, oh, I'll give neat cutting oil a try, because I've been using the Mister system with the soluble oil. That works fine. Although there's some things where I've been using the RTD just because it seems to work better, harder materials, that sort of thing. So it'd be interesting to see how well that works, because that RTD's horrible sticky stuff. Probably 6 months ago at least, I got a new spindle. It's a 1.5 kilowatts air-cooled spindle for my CNC machine down here, but unfortunately the bracket on there is for the existing motor, which as you can see is somewhat smaller, and the other one, which is there, is too large. So I have 3D printed a pattern, which as you can see has got a fair bit of draft on it, so I'm going to sandcast that one just for simplicity, and then machine that up. So that'll be an upcoming video. Give you an overview of casting process and then a quick bit of machining, and hopefully get this spindle up and running on there. I also bought this purely because it was comically large and not very expensive. I got it for about 50 quid. I'm sure I could sell it for more than that. It's a Morse Taper 6 by 3.1 inch drill bit. I don't have a machine that will fit it, and there aren't many machines that have a Morse 6 on them. It's a big it's a big tool, but it was just comically big. I think that's about it for the moment. As you can see, I've just got lots of little bits going on. Trying to clear some things out of the way so I can get stuck into some more projects. I hope you enjoyed that. Thanks for watching.